We've learned how to deal with data where the standard deviation or the variance of the population that we're comparing our data to is unknown. Right? We talked about how we can use a one sample t-test to test whether or not a sample of data that I have came from the null hypothesis population or the research hypothesis population. Right? We can do this if we know the mean of the comparison population, the null hypothesis. We know the mean of that population, but we don't know the variance by estimating the variance from our sample. We also looked at how if we have two groups where we have sort of a before and after where the data is related, we can look at that difference score and see if it's different from zero. Right? By estimating the variance, we introduce bias, and that's what introduces the t-distribution, and hence we're doing t-test. The last example that we haven't covered is where we have two independent groups. Say, for example, that researchers predict that having a boy or girl affects the rate of divorce after having a child. This is something that sociologists and psychologists have looked at over time, and there is potentially a pattern there. So if they wanted to look at the mean number of years after a child was born and compare that to whether it was a boy or a girl to see how long it took for a divorce to occur, if a divorce did occur. Right? What is the experimental hypothesis here? Right? The experimental hypothesis is that having a boy or girl will affect the likelihood of getting a divorce. We're comparing the mean number of years to get a divorce after having a boy versus the mean number of years of having a girl, right? So we have two means in this case. Right? And the research hypothesis, the experimental hypothesis, states that that difference between the means is not zero, right? If the null hypothesis was true, what would the difference in means be? The null hypothesis says there is no difference between boy and girl and the mean years of having a divorce. If there's no difference between having a boy or a girl, the difference between the boys and the girls in terms of their means should be zero, right? The difference between the means of these two groups is zero if the null hypothesis is true. Now, because of sampling error, right, because of random sampling effect, the means are not always going to be exactly zero, even if the true mean is zero, and that's why we test the significance of any difference we see. Right? The research hypothesis says that the difference between the means, right, is going to be big enough that its likelihood of coming from chance alone is too slim, that's our alpha, and therefore we say that the research had an effect, that boy or girl had an effect. So the question that we're asking is, what is the difference between the two means of the population? Right? If the null hypothesis is true, the difference between the means should be zero. Right? If the null hypothesis is not true, then we should see a difference in these means. Of course, we need to modify the difference of means. We have to normalize it to the variance of the population. But which sample do we use to determine the variance of the population? We have the sample of boys, we have the sample of girls. If we're assuming the null hypothesis, right, we're calculating the variance of the null hypothesis distribution. Right? Then the boys and the girls are basically the same samples. We just have two different groups to estimate the variance from. Well, which should you pick? We know how to do it with one group, right? We've done that. That's what we did in the last chapter. But what happens when we have two groups? Well, we use both groups, and that's the biggest change here. The biggest change when we have two independent groups is we have to use both groups to estimate the variance. So in this case, we are going to use what's called a pooled variance. So we are going to take the estimated variance, right, calculated by the sum of squares divided by the degrees of freedom for group 1. We're going to take the variance, the estimated variance from group 2, right? That's, again, the sum of squares divided by degrees of freedom, right? And we are going to combine these together into a single pooled variance based on the degrees of freedom of each group, right? This is a weighted variance. So if the two groups have an identical number of samples in them, 10 people or 20 people in each group, then it's just the average of the two estimated variances. If one group has 30 and the other group has 10, we should trust the group that has 30 more than we trust the group that has 10. And so we're going to take the degrees of freedom from both groups and we're going to divide by the degrees of freedom total. Right? So all it says is that, let's say one group had 30, the other group had 10. So this group has 29 degrees of freedom. This group has 9 degrees of freedom. And we have a total of 38 degrees of freedom. And then we're going to take the fraction, right, 20 divided by 38 and 9 divided by 38, so that we're actually going to weight this estimate more than this estimate because it has a bigger degrees of freedom, right? So this is all we're doing, is we're just taking the pooled variance, right? Then we have to divide by n to get the variance of the distribution of means. This is the exact same thing as we did in the last module, right? Except now we're having to do it with the pooled variance. So we do it once for the n of the first group, and then we do it again for the n of the second group, and then all we do is we combine them together into a single estimated variance, take the square root of that for the standard deviation, and we're done. Right? So that is the only major difference, is we're having to work with this pooled variance, right, from both groups instead of a single group. Other than that, the logic stays the same. The t-test, right, is the difference between the means. Right? If the null hypothesis is true, we assume this is 0. If the null hypothesis is not true, if we can reject the null hypothesis, this difference will be bigger. We modify it by the estimated standard deviation. Right? And if it exceeds our t-threshold, right, that we look up in the back of the book, we can declare that we can reject the null hypothesis. And that's all there is to the logic of an independent t-test. Let's take a look of it in action. So here we have some data relating child gender and divorce. So we have 20 couples who had girls and 20 couples that had boys. These are couples that ultimately got a divorce. And we have the number of years after childbirth that they got a divorce. And our question is whether or not there is an effect of gender on girls and boys, right? So remember, our first step in hypothesis testing is to write out our hypothesis. So our research hypothesis says that, right, so the research hypothesis says that gender has an effect on divorce rates, actually, let's make it a little more specific, has an effect on the number of years after birth that couples get a divorce. And then the null hypothesis is simply that gender has no effect on the number of years after birth that couples get a divorce. All right, so now we need to figure out our sample averages. We need to get our means for our samples. Right? So the mean years for girls is 2.5. The mean years for boys is 4. Right? So let's see if that's a significant difference. Right? We don't know the variance of the population that these groups have been selected from, but we can estimate that variance by looking at the sum of squares for each individual group. So we're going to take each data point for the girls and we're going to subtract the mean, and then we are going to square that result, and we're going to do that for every single data point, and then we are going to get a sum for all those points, and that gives us our sum of squares for girls. And now we're going to do the same thing for the boys. So we're going to take each data point for the boys, we're going to subtract the mean of 4, and we're going to square that, and we're going to do that for every single data point for the boys, and then we are going to get the sum of squares for boys, which is 62. Okay, so then we can get the estimated variance of the population for each group, right? So the estimated variance for girls is going to be equal to the sum of squares divided by the degrees of freedom, which in this case is 19. Right? And the estimated for boys is going to be the sum of squares divided by the degrees of freedom, which is also going to be our degrees of freedom divided by it's also going to be our sum of squares divided by the degrees of freedom. So far, this is exactly what we did in the last module, except now I'm doing it for two different groups, and I have two different estimated variances. Right? And as we learned, we now have to pool these variances. Right? So remember, we have degrees of freedom for group 1 is equal to 19. Degrees of freedom for group 2 is 19. So the degrees of freedom total is going to be both of those combined, which is 38. So now we have to do some pooled variance. So our pooled, remember the goal is to do a weighted average of the two estimates. So we take the degrees of freedom of the first group, which is 19. We divide by the total degrees of freedom, which is 38. And then we're going to multiply that by the estimated variance for girls of 1.4. Now we're going to add that, the weighted average, same thing, for the boys of 3.2. That gives me my pooled variance of 2.3. Right? So now I have to estimate the variance for the means for group 1, which is 2.3 divided by 20, right? And for group 2, right, it's going to be the same thing, 2.3 divided by 20. Then we add them together, right? So our actual variance, or the difference score, right, is going to be 0.115 plus 0. The actual variance for the two means is going to be equal to 0.115 plus 0.115. And then we get the standard deviation of the difference score. We just take the square root of the 0.23, and there we go, right at 0.48 is roughly my variance. Okay, so there's extra steps here. There's a lot of steps here. If you just remember each of the steps, and remember it's the exact same thing we did before, we're just using that average variance to calculate this. Now we can do our final t-test, right? Where we're looking at the difference of the means. So we have girls is 2.5, boys is 4, and we divide by my estimated variance of 0.48, and we find, which is going to be well above my threshold that I can look up in the back of the book. Right? So that's how we do the two-sample t-test.